Okay, what'd you guys get for A?
I, B. I got I.
5, yes, isosceles, right.
I was right in your face.
Isosceles means two equal sides, right means as a right angle. Okay, B.
2.
Scalene, right. What does scalene mean?
If none.
No equal sides. And it's got a right angle also. C, okay. C they kind of screwed up on actually. The book screwed up on. What kind of triangle is that though? It's, well, actually it's not right. They made it, they drew it so it looked like it was right.
4.
But if that's there, what kind of triangle is it for sure? Isosceles. Okay, on an isosceles triangle, remember we know that the base angles, the angles across from the equal sides, are going to themselves be equal. So these both have to be 40. So if these two are 40, what's that leave for this angle right here?
The rest. So
100.
Oh. Oh, yeah.
Okay, 40 plus 40 is 80. 180 minus 80 is 100. So the answer should have been obtuse isosceles. Isosceles obtuse. It's not an option. I believe they meant to put that on number 4. Isosceles obtuse.
I just went off with the 4.
Possibly they meant to put it on number 1.
Can I put 6?
So that's what we put, not an option.
Instead of 4. Can I just like add 6? And then
6 is already
I
one
thought
regular.
Sure. You need 7.
Or just put 4 and put that in 2.
Yeah, just scratch out the acute on 4 and put obtuse. Okay, and then on D, what kind of triangle is that?
Regular, so 6.
Yeah, we didn't, regular means equal sides, equal angles. We didn't even call it regular usually though. What do we actually call it? Equilateral. What would each angle in the equilateral triangle have to be? 60. 180 divided by 3. Okay. Number 2, state which triangle congruence postulated theorem can be used to prove two triangles are congruent. Okay, let's see if we can remember them. What are the postulates or theorems to prove?
SAS, IASI, SSS, angle, side, hypotenuse, leg.
Okay, that's it. There are 5.
Is that for A?
No.
Darn.
Well, one of them is right. So those are the 5 ways. That would probably be a good note to write down also. Those are the 5 ways to prove triangles are congruent. So for A, which of those
SAS.
would apply? Actually, I'm going to give you guys another minute. Why don't you try to do A, B, C, and D? None is an option. None is an option if you read the directions. So mark that go.
Wait, can there be more than one answer?
No, there's only one up. They're all different.
So there's not an answer.
I don't think so. No.
I'm pretty sure all of them have an answer.
They're all different.
But one of them is not. Two of them is not.
Huh?
What does H mean?
Hypotenuse, leg.
Hypotenuse, leg.
Ooh, I think I remember what.
Those girls. A long time. Hmm?
Maybe I don't think I learned the middle school.
Oh, whoops, I went 20 seconds over. Okay, B. So what do we know on B that is congruent that they do not show? Vertical angles. So if those The vertical angles are those angles in the middle. So if those are congruent, what do we got?
SAS.
No.
ASA.
ASA.
Yeah!
I was right.
Isn't that what I said?
No, you said
Angle
side
side.
to side.
Are very tight.
What's up?
I said
Gosh, no, you said it.
That's what I was telling you about, across.
Oh, I was
Is that
so
what you guys
confused
want?
because I never had the front. I had to put it back.
Why do you have a
You
frog?
looked at me.
From the kid.
And then you said you were frog.
Did you see or did you paper?
Yes.
Oh, fire. You know when they start their practice?
Anybody catch that and help the sense into a friend?
No.
It's got a crown and all.
Well, she said she needs to go practice.
That movie is
But
Basically,
don't know what to
every
do.
week took so long, and the girl behind was like, can you please hurry up,
You go.
please? She kept pushing me too. Yes.
All right. C.
HL?
Okay. Do we know? Yeah. HL only works on right triangles. That looks like a right angle, but they don't tell us it's a right angle.
It would be the bad word, don't
So, yeah, if it was a right triangle, it would be hypotenuse leg. That would be a hypotenuse leg. But it's none. It is none.
Okay, so I would have been right if I was. Yeah.
Okay.
I just thought it was right.
If it was a right angle, hypotenuse leg would have been right. D.
SSS.
Side, side, side. Because they share that side in the middle, we know that's a congruent side.
D is side, side, side.
Yeah. Got it? 4 for 4.
No.
Okay.
I thought HL was missed.
Number 7. This is actually, number 7 is actually chapter 6. They're kind of jumping around here. Opposite sides of a parallelogram are parallel and congruent. Wait, did we skip one?
You missed almost
All page.
Oh.
3, 4, 5, 6.
Oh, this copy is screwed up.
Hey, I have a bad copy too.
Yeah, we don't have people. I do. We have good copies.
Copies, let's go.
Who has bad
Who has
copies?
2, 4, 5, and 6?
Let's see. I have a bad copy.
I have 2, 4, 5, and
Hey, let's
If you have,
Loser.
if you have number 3, you have a good copy.
Oh, I have a good.
Yeah. Wait. Which one? That's why we have good copies. Oh, you're so bad.
I was wondering why it went directly from the triangle.
Oh, but this is no. I saw that.
Where? No, it's a bad
I was gonna.
I am a big
Oh.
Okay, actually, let's go on to chapters, or number 7, so that by the time these copies are done,
Dragging me down.
You all have the back copy.
No.
we'll come back and do number 3.
They have extra work to do.
We're just better.
No, you have extra work.
We're just better.
But you want to know that.
Are you judging me?
Because you,
This is why you need a book.
they'll be acting more balanced.
We're just better.
You give me a dollar.
Your butt up.
I have to.
No, I don't. You're the, no.
I did.
I said, no, you said all I did.
Oh, I did this last.
Why would you put your butt on face and you throw your neck?
Oh, yeah.
And you never know. Except Erica.
All right, number 7. Okay, opposite sides of a parallelogram are parallel and congruent.
Wait, what? Parallel and congruent. It's all on here.
Oh, 7.
7A.
Okay, B, consecutive angles of a parallelogram are Supplementary, they have to add up to 180. Consecutive means next to each other. Consecutive angles of a parallelogram are supplementary. A was congruent. C, the sum of the interior angles of a parallelogram is
N minus 2.
360. All, actually not just parallelograms, all quadrilaterals are 360. Okay, D, each diagonal separates the, I think they meant to say parallelogram. Each diagonal separates the parallelogram into two congruent triangles. Alright, number 8, always, sometimes, or never. These usually kill us. A kite is a square.
Never.
Okay, never. A kite, if we had done page 2, we would have talked about this. A kite has two consecutive pairs of congruent sides, but they have no parallel sides. A kite doesn't, so, and a square does. So a kite is never a square. A parallelogram has perpendicular diagonals. Thank you very much.
You're welcome.
Never. Wait, sometimes.
Sometimes, you guys know when it happens, what kind of parallelogram has perpendiculars? Rhombus, and square is a type of rhombus also, so sometimes, oh wait, not for you. Who needed a good one?
Trash.
But I got
I gave you a homework.
I can't control all my notes. And then putting batteries for it.
Yeah, probably best throw them away for next year.
Getting bad.
Okay,
Who moved?
no. Okay, you don't have to copy them, you can just keep them on the other page. I forgot where I was at. C? Yes. A quadrilateral with a pair of opposite sides that are both parallel and congruent is a parallelogram. Always. That's one of the ways you prove a quadrilateral is a parallelogram. If the opposite sides are congruent, or if the opposite angles are congruent, or if the opposite sides are parallel.
What was
B, sometimes. D, a trapezoid has exactly one pair of opposite angles that are obtuse. Oh, I think I said this wrong in the other class, actually.
No, it doesn't always. Because it can have two right angles.
Okay. In a trapezoid, I don't know how to say it. So, what do we know, like, on these two angles in the trapezoid? What do we know about those two? They add up to 180. Yeah, and these two also. But opposite angles, will these two ever be the same? That's the question. No. If they were the same, then this would be a parallelogram, not a trapezoid. So, no, never. If we would only listen to you, Jake, you don't have to do so much stuff.
Is that something you're gonna test?
Probably not. I don't really like those. They usually,
We're missing 3 pages in this.
people usually get it wrong.
I'm
What?
gonna get it.
We're missing 3 pages in this. It's not just that second page, it's also the...
Did you get number? Did you get number
It's also the
3?
fourth and the fifth.
Did you get number 3 though?
Yeah, I do have numbers for you now, because you gave us the new ones.
Okay, on number 9, do we know for sure, this is yes or no, that A is a parallelogram?
Yes.
Yes. Opposite sides are congruent is one of the ways. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect. One pair of opposite sides is congruent and parallel. Those are the ways
Opposite sides are congruent.
angles are congruent. I'm sure you have one of,
I lost those ones. I don't know where they
Opposite
went.
sides
Probably
are
not.
angles are congruent.
probably in that pile somewhere. I just like said yesterday, I'm surprised you.
Wait, opposite angles
Kept on
are
going.
congruent.
Opposite sides are congruent, opposite angles are congruent, diagonals bisect,
Oh, wait.
one pair of opposite sides is congruent and parallel. Oh, also if consecutive sides are, consecutive angles are supplementary.
I mean, if the one angle's right
Well, that's if we know it's parallel.
down.
Okay, on,
What's the last one that you said? Other than
if
supplementary.
consecutive angles are supplementary,
No, the one before that. The last one that is.
one pair of opposite sides is parallel and congruent.
We leave at 50, huh? We leave at 50.
Oh, today's, oh, this is one hour.
Okay, B,
Never said that.
do we know that B is
No.
parallelogram?
Yes, ma'am.
Okay, no.
Yeah.
We know one pair of opposite angle or sides is congruent, not two pairs. On A, we need both pairs. We know one pair of angles is supplementary, one pair of consecutive angles, but we don't know, that's not enough information. We don't know all the consecutive angles are supplementary. Or we don't know both pairs of opposite sides are congruent. Anyway, C.
Yes.
Yeah, how do we know C is a parallelogram?
They bisect.
Diagonals bisect. Okay, D is kind of the trick question, kind of like, they always say the hardest one for last, but. Okay, on D, we know those two angles are parallel, or congruent. Is that enough to say it's a parallelogram? No. If both pairs of opposite angles are congruent, it is. But it also tells us these lines are parallel, which means these angles in between, remember they're called consecutive interior angles, are supplementary. Like these two have to add up to 180, and these two have to add up to 180. Therefore, supplements of congruent angles are congruent. So we do know the opposite angles are congruent. So yes, for D. D is yes.
You trying to find one.
That's what I know, right? I just might have to just copy this page and then you take it apart and then I was trying, look.
This only has,
You could just copy
this is missing more than one page.
One. Yeah, it's missing 3 pages.
Whoa, I just erased one.
Yeah, it's missing 3 out of 6 pages.
I wonder where it goes.
Okay,
Years ago.
Okay, 10, I don't really like 10, but we'll talk a little bit about it. Does anybody remember what reflexive property was?
It reflects.
A equals A. You can just write that down. We're not going to do all the directions. That was a property of equality or equivalence relation or whatever.
Wait, what number on our cheat sheet?
10A. Nah, you probably don't need this for your cheat sheet. A equals A. So they said something like the relationship of having the same age. So that would be like your age is equal to your own age. Kind of dumb. Does anybody know symmetric property? If A equals B, then B equals A. Surprised you guys remember some of this stuff. Some people did. Transitive property we actually used. All right.
A equals B, B equals A. I'm gonna cry.
If A equals B and B equals C, then what? A equals C. Okay,
Yeah, you didn't see.
skip the equivalence relation. I don't know what they wanted for that, actually.
Getting mad at me.
Okay,
Now 16.
back to number 3. Back to number 3.
Alright, we don't have to do it. Goodbye.
What's D?
Put the candy away.
Yeah.
I'm about to take it away.
Let's skip the next two questions.
Put it away.
I'll take it if she doesn't want it. I'll put it away.
Okay, Mari, you got a detention.
Ooh, I had that before.
Alright, number 3. State the, okay, this kind of goes back to the triangle congruent stuff that we did earlier. So like side, equal side. State whether each listed right triangle congruence theorem is a corollary of a general triangle congruence postulated theorem. So in other words, is HL like the same thing as side, or something? Okay, HL is not the same as anything, because if it was, then we wouldn't have listed it as one of the possible things. So HL is different than all these. That's why we list it separately. Anyways, A is none. Let me erase this. Okay, and LL. What do you guys think they mean by LL? Like. So what they're saying is if we have two right triangles, you guys remember what legs were? These were the legs. This was the hypotenuse. So what they're saying is if you have both pairs of legs congruent, then basically what do we have here? Side angle side. So we didn't call it leg, we just call it side angle side. Anyway, so side angle side would be B.
What did we get for equivalence property?
We didn't put it down. We just kept that.
So where are we going? We're at
3, number 3.
3 now? Why didn't we do
Number 3.
What was D?
Number 3.
It was SAA or SAS.
SAS.
Okay.
Leg angle.
The next one is leg angle. So this one's kind of a little bit of a trick because it could be like this leg and this angle, or it could be like this leg and that angle. So there's a couple different things. If I put this leg and this angle, what do I have here? Angle, side, angle. So that's one of the answers for C. Okay, but also it could have been this angle down here in this corner. So in that case, what do we have? Angle, angle, side. So C actually has two answers. Could have been angle, side, angle, or could it be angle, angle, side?
Mr. Jordan,
Yeah.
you know how you have a page front and back of the notes? Can I print mine out? It's the same size of paper.
Wait.
Yeah, I can print. I don't know. Why would you do that?
Yeah.
No reason at all. Yeah. Yeah. Okay, and then
No, it's not.
HA,
This and then on each side, like, and then I'm printing out
hypotenuse,
the sheet.
angle.
It says,
Did we get it?
each, like, the chocolate and everything. all
Okay.
the-
Hypotenuse, angle. Doesn't really matter which angle I choose on this one. What do I have here? Angle, angle, side. So hypotenuse angle would also be like an angle, angle, side.
I'm gonna fill them up all on each side.
No way.
Okay, number 4, this would be a really good one for notes because it's easy. Most of these are pretty good for notes, but it's pretty easy to forget number 4. I think this was chapter 5. You guys remember number 4? What kind of lines are drawn in the picture on number 4A?
Right altitude.
Altitudes. Altitudes go from the vertex straight down. It's like measuring the height of the triangle. Okay, but the question that they're actually asking is, what is the point that the altitudes meet at called? What's that again? Orthocenter. Yeah. That's kind of hard to remember that one. All 4 of these are kind of hard to remember. So A, those meet at the orthocenter.
So we'll be right on A.
Orthocenter.
On A.
Oh,
No.
Yes.
isn't on B if it goes to the medium, the
Yeah. Yeah. Well, the lines are called medians, not the point. Okay, on B, what are those lines that go from the vertex to the middle called? Okay, it means the lines are called medians because they go to the middle of the opposite side. And the medians meet at the centroid. Centroid.
I remembered it, I didn't take it.
I'm in believe.
The centroid, another kind of important note for like number 5. The centroid, the centroid is equidistant from each vertex. Can you guys see that in the picture on B? The centroid, that point, is the same distance from every vertex. We kind of need that for number 5. Okay, C. What kind of lines did they draw on C? Angle bisectors. Where do the angle bisectors meet at? Well, what's point P called? Yes, it's called the incenter. That means it's called the incenter because if you draw a inscribed circle inside there, P would be the center of it.
Where's P?
We're looking at
Oh,
4C. On 4C, the P is called the incenter. And then D, what kind of lines are those that they drew? Perpendicular bisectors.
And then the middle.
And they meet at the circumcenter. Because if you draw a circumscribed circle around that triangle, P would be the center of it.
Where do you get angle?
Huh?
Like, on C is an angle bisector, where do they join?
Oh, they meet at the incenter. Okay, number 5. That was angle side. Okay. Determine whether each statement. Okay, this is true or false. Is XD equal to XE?
Yeah.
So basically what they drew there, the BX, XC, and XA, those are the median, or not the median, those are the angle bisectors. So it's kind of like numbers, or letter C on the last problem. BX, XC, and XA are the angle bisectors, and they're going to be equidistant from the sides. So XD and XE are actually the same thing, yes, true. Okay, are AX and BX the same thing?
Wait,
No.
BX is not
No. If those were medians, the answer would have been yes, but they're not medians. AX and BX are not the same thing.
Whoa.
False. Okay, DC, DC and EC, are those the same? Yeah, basically by angle side, those triangles are congruent up there. So yeah, DC and EC are actually the same thing. So yeah, true.
Wait, so D is full?
Yeah. Okay, and then on D, no I did. DAX is equal to twice DX.
True.
You guys probably forgot this one, but remember that AX was 2/3 of the way of AD? So yeah, AX is twice DX, that is true. True, false, true, true. That's what it was.
Is this the last question?
Well, when do we get out?
55.
50. We
55?
got
So why is B?
This is, wait,
It's just not.
It's Wednesday,
it's
though.
55. Yeah, I think it's 55.
no.
So why is B false?
Yeah.
We should do.
I forget the passing.
Those are not, yeah, it's not B, it's C.
We should
The,
just do number 6.
C's
Number 6 looks kind of.
okay,
No, it's
no.
not easy.
I guess
I'm
true,
saying on the
false,
last
true,
problem,
true.
it's like C, not like B on the last problem. On, the incenter is equidistant from the sides,
Yeah.
but it's not equidistant from the vertices. And if you look carefully, you kind of tell it's not the same. Like if you measure it carefully, it's not the same. Okay, anyway, 6. Okay, well, this is the test we just took, right? Chapter 6. A quadrilateral with 2 pairs of parallel sides is a
2.
parallelogram.
This is the last pack. No way,
Yeah. We're not going to finish it today, though. B, a quadrilateral with 1 pair of parallel sides. Trapezoid. C, a quadrilateral with 2 pairs of congruent consecutive sides and no parallel sides.
1 kite.
Kites. A rectangular rhombus.
5
Square. Rectangle means equal angles. Rhombus means equal sides. What has equal angles and equal sides? Square.
Is Rosalie gonna do it on the test?
Huh?
Are you gonna do it on the test?
No. Some of them might be.
11?
Can we stop here?
No. We still got like 6 minutes. The other class we got to like 14.
Well, we are not going to.
We might not make it up.
Let's get to 15.
Yeah, beat the other class. Okay, on 11, so what, on 11, you see how AB and BC are the same? And GF and FE are the same? If it's cutting those segments equally, that means those lines have to be parallel. That's basically what that means. So what shape is ACEG? What shape is ACEG? Trapezoid. Okay, also all those lines that look parallel are parallel. Okay, so in that case, how can I find angle CEV? Well, I know what angle ECD is. Do you guys see angle ECD? What does angle ECD have to be?
55.
Why does that have to be 55?
Because it's the same angle as A.
Because it's, yeah, it's called a corresponding angle. They're parallel lines. Right here. If this is 55, this is 55, because the lines are parallel. Corresponding angles. And this, okay, I screwed that up. This one was 50. So how do I find, the question one though was what's this angle right here? Yeah, 180 minus these two. 75. Okay, how can I find angle ABF? I'm not sure the other class figured this one out.
This one is good.
So if A is
Or maybe they
55
did.
and D is 50, so that would mean that F would be 50.
No, you didn't make it too hard. Okay, these two lines right here are parallel, right? So what do I know about angles between parallel lines?
F180.
They add up to 180. So it's just 180 minus 55.
125.
Yeah, 125.
I don't think that would be the answer. The above is stupid.
Okay, C you cannot figure out unless you read the directions. And the first time I did this, I did not read the directions. It says in the directions that C and E are midpoints of AD and GD. So, which means CE is like the mid segment. It's the one that's right in the middle. And yes, CE has to be half the length of AG. So yes, CE is 5. A mid segment of a triangle is half of its base. So CE is half of AG, so CE is 5. Okay, now how do I find BF?
Average, so you add 10 and 5 together.
Right.
And then you divide by 2. which
This is
is
called the
75.
mid segment of this trapezoid. And it is the average of its bases. Remember doing that? To find the mid segment, you average the bases. So you do 10 plus 5 divided by 2. 15 divided by 2 is
7.5.
7.5. Okay, number 2. Too much?
I have to rewrite the document.
There's unstable and unstable.
That wouldn't do it.
Well, I don't know.
Okay. Anyways, number 12. Guess what? We can kind of just look at the picture and guess where they're going to ask you. Probably. What are we going to do on 12?
Find the variables and
Find y and x. How can I find y?
Plus 7 equals.
Right. The way they ask it is, what does y need to be to make this parallelogram? The opposite sides need to be equal. So y plus 7 needs to equal 4y minus 2. And so we solve that for y, and then 3x needs to equal 2x plus 2. Okay, why don't you solve those both for x and y, and then we'll call it.
add the answer.
No, I do not want the answer, Will.
Can I do it by giving it on the board first?
No, do it on your paper.
George, we can start doing that.
Time to do your math.
That was good, Will. Wait, so you solve it now?
Is it?
Don't say it out loud.
What? This is the stuff you knew how to do.
I never said I knew how to do it.
You've done this like multiple times.
I never said I'm good at it.
You subtract 4y or subtract 1y.
No.
What do you guys get for y?
X minus 4, minus 5.
4 and 5, okay.